This is about, well, this is a hack, a fun hack to create a login system for PeerPad.
Okay, cool.
Okay, so you can go here and change your um, your name, and it's just a CRDT, so there is no there's no authenticity to this data. So what would be fun, we thought, would be to use MetaMask to provide some type of identity. So MetaMask, for you that don't know, but Juan can explain what it is.
Yeah, so MetaMask has two, offers two main properties. The first one is that it offers a gateway to the Ethereum network. So in a browser environment, it exposes an object which you can use to query the Ethereum network, issue transactions, read the state of the network. But it also acts as a wallet for your Ethereum keys. So even without being connected to Ethereum, you can sign and verify transaction signatures and digital signatures as well. And MetaMask also implements some ways that you can sign messages. So what we thought is it would be cool to use the MetaMask account to sign the IPFS ID, which is what right now is being used to authenticate users on PeerPad, just the node ID. Yeah. So we started by just signing the IPFS ID and then sending that signature to the other person alongside with the MetaMask address, like the Ethereum address, which is a public key. And then the other peer could verify that signature and say that, OK, so this IPFS peer ID belongs to this Ethereum account. Then we took it a step further, which is, well, you can actually use an Ethereum smart contract to prove to place some proof of personhood inside it. So you can point it to your Twitter account in which you say, hey, this is me, here is my Ethereum address. You can point it to a Facebook account as well. You can point it to your social security card, whatever. You can put any number of proofs of personhood inside an Ethereum smart contract. So from there, what we did was, instead of just signing the IPFS ID and sending the IPFS ID to the other node signed, we sent the same signature, but with an address of a smart contract. And then in order to verify the message, what the node does is it goes to the smart contract, which has my public key, my Ethereum wallet key, gets the key from there, can also query the smart contract to make sure that I'm who I say I am, and then taking that key verifies the signature of the IPFS ID. I know this is super confused, but we'll give it a better look once you look at the smart contract. But in the end of the day, what happens is you get the person's name right there.
Let's refresh.
Huh?
Let's refresh.
Oh, yeah. So cool. So when we join PeerPad, the sign in right now would be for you to sign a MetaMask message. I'm not sure why it's not requesting me to do so. Wait, maybe it's just not there yet. What's happening here?
Can you refresh?
Yeah. Let me see if it's. Oh, OK, so it's here. So right now it says that I am sending my IPFS ID. So I signed that. Pedro did the same, right?
Yep.
Yeah, so now our nodes are querying the smart contract, getting the key, and verifying the signature. They are also grabbing any proof of personhood that might be in the smart contract. And in this case, it's like a link to a Twitter post, which you can then open and see that this is indeed Mr. Potato Potato. And that's the so in this case, it's this would be the link to your Ethereum wallet address. In this case, we used the wrong Twitter link, so it's pointing to an IPFS object. But in the same Twitter feed, there's the Ethereum address. So what's happening here in the smart contract is, so for every user, you have a smart contract. Every smart contract corresponds to one identity. And then you can query a bunch of stuff from that identity. So in this case, I am using this one. This is the address of the smart contract we are querying right now, which is my smart contract. And you can get a bunch of stuff from it. So you can make sure that it has not been revoked. You can get the nickname. You can get the owner, which is this public key right here, which corresponds, so it's 064810, which corresponds to my Ethereum wallet address right here, because I created this smart contract using this address. And then from there, you take this key and you can verify the signature on the other side. Yeah, so that's that.